Okay, good days, everyone. I'm Veron. Welcome to our forum. Today, we are exploring a critical intersection that defines modern manufacturing, the link between workplace safety and environmental management. To truly set the stage of our discussion, we have to acknowledge an essential truth. Modern safety is not accidental. It didn't not emerge overnight. Instead, it evolved through a historical timeline and hard-learned lesson. Shifting from the 1844 British textile factory legislation, moving to our own local legislative milestone like the Factories and Machinery Act FMA 1967, and eventually culminating in the groundbreaking Occupational Safety and Health Act OSHA 1994.
That's exactly right, Veron. If you look closely at the timeline, OSHA 1994 changed everything in Malaysia. Before 1994, under the old FMA 1967, we are operated under we call a predictive system. The government acted like a strict headmaster telling factory exactly how thick a guard rail had to be or how many feet of clearance a machine needed. It was completely dependent on enforcement and government inspectors. OSHA 194 flipped that narrative entirely by introducing the philosophy of self-regulation.
Let's pause on the word separately. For those listening who might think that means companies get to proceed themselves without oversight. Could you clarify what it actually implies in practice?
It's actually the exact opposite of a free pass. Self-regulation is based on a foundational philosophy. The responsibility for safety lies with those who create the risk and those who work with the risk. The government realizes that an external inspector doesn't know the daily macro hazard of a production line better than the plant manager and the floor operator. By shifting the legal burden, the law mandates that the employer and employees must collaborate to build their own safe system of work.
And if I may add, this historical shift is what the way for modern risk management framework like high hazard identification, risk management assessment, and risk control. Under the old positive law, you just follow a checklist. Under self-regulation, you are legally required to proactively hunt for hazard using tools like the 5M man machine material pattern and media. Beautiful part. Today, each our expert will break down a major industrial hazard and show how we manage it through this legal, historical, and practical lens. Syakirin, let's start with an invisible yet incredibly pervasive threat on the factory floor, a silent hazard for workplace noise.
Thank you, Veron. Noise is a fascinating hazard because it often overlooked simply because it's invisible. Unlike a chemical spill or unguarded gear, you can see some wave traveling through the air, but its consequences are permanent and devastating. Occupational noise-induced hearing loss (NIHL) or standard workplace deafness cannot be cured. Once the hair cells in your inner ear are destroyed by excessive exposure, they are gone forever. In the field of OSH, we make a strict distinction between sound and noise. Sound is just a natural phenomena, a physical variation in atmospheric pressure. Noise, however, is defined specifically as unwanted, erratic, or damaging sound.
For our audience running manufacturing facilities, how do we scientifically measure when a sound across the line and officially become a workplace hazard?
We measure sound using the decibel dB scale, specifically using a wave filter expressed as dBA, which mimic the human ear sensitivity. Now, here is what tripped most people up. The decibel scale is logarithmic, not linear. This means a small increase in number represents a massive exponential increase in actual sound energy intensity. For example, a 3 decibel increase actually double the sound energy. Psychologically, we look at two main milestones. The first one is the threshold of discomfort. The threshold of discomfort generally sits between 85 and 95 decibel. This is where your body starts reacting. Your heart rate can slightly elevate and prolonged exposure begin cause damage. The second one is the threshold of pain. The threshold of pain hit between 120 and 140 decibels. Think of a jet engine or pneumatic rivet gun at close range. At this point, immediate acute acoustic trauma can occur. Under our local mission framework, specifically the Occupational Safety and Health Noise Exposure Regulation, the permissible exposure limit (PEL) is strictly set at 90 decibel for continuous 8-hour shift, with a maximum peak limit of 115 decibel at any given time.
Okay. From a risk assessment and clarification perspective, if you look through the lens of 5M framework, noise is especially categorized as a media hazard, correct? Because it deals with the immediate environmental condition and the workspace.
Exactly. It belongs to the media category, right alongside lighting, ventilation, and thermal comfort. Now, once our hierarchy process identify a noise hazard exceeding 85 or 90 decibel, self-regulation dictates that we cannot just jump to the easiest solution. We must rigorously follow the hierarchy of control. Let's look how we apply this invented pyramid to noise compression room. The elimination of substitution. Most effective, this means completely removing the source. We can substitute an old roaring piston compression with a modern ultra-quiet rotating screw compressor. Can we eliminate the process altogether by us scoring that specific heavy stamping task? Next is engineering control. If we cannot remove the machine, we isolate the hazard. We put acoustic enclosure around the compressor, line the wall with sound absorbing material, or install silencer on exhaust valve. We alter the physical environment. For the third one is administrative control. We shift the focus to how we manage the man and method. If production zone read at 93 decibel and administrative control would involve rotating workers shift, so no single employer spend more than 3 to 4 hours in that zone. Keep their time weight average TWS safely below the legal limit. It also includes mandatory annual audiometric testing to catch early sign of hearing degradation. The last one is a personal protective equipment, which is PPE. This is a bottom of the pyramid, handing out earplug to earmuff. In professional OSH practice, PPE is always treated as the least preferred, absolute last resort. Why? Because it doesn't remove the hazard. It only put a thin barrier over the worker. If an operator pull out an earplug for just 10 minutes to talk to a colleague, their protection for the day drops dramatically.
That's a seamless transition to our next topic. Noise damage over years, but chemical mismanagement can cause catastrophe in second or create long-term chronic illness. Hadi, industrial operation depend heavily on a raw material and chemical. How do we address the material side of the 5M?
Okay. Chemical hazard represent an extraordinary challenge because of how workers interact with them. Every single year, we see several industrial accident, chemical burns, toxic inhalation, long-term respiratory diseases, not because the company lack safety rules, but because of what we call inappropriate response. This is a core concept from the human factors theory of accident causation. The theory shows that an accident occurs because a human detects a hazard but fails to correct it due to fatigue, for training, misjudgment, or systemic pressure. For instance, a worker might smell a solvent vapor, recognizing a leak, but they choose to keep working without a respirator because they want to finish their quota faster. To prevent this human failure, the most vital legally mandated communication tool we have is the safety data sheet or SDS, formerly known as the material safety data sheet or MSDS.
Let's drill down into the compliance aspect. Why is the SDS considered the ultimate legal and operational document for chemical handling?
Because the SDS bridges the gap between raw data and human action. It contains 60 mandatory sections that outline everything a worker or emergency respondent needs to know: chemical identities, threat hazard, firing, safe storage condition, first aid measure, and specifically the precise type of PPE required. You can just write wear glove on an SDS. It must specify what kind of glove, like nitrile, neoprene, or butyl rubber, because the raw material can dissolve when it touches certain solvents. Under OSHA 194, employers have a non-negotiable general duty to provide the safety information, translate it into accessible language, and run comprehensive training program. Furthermore, in industrial or higher education institution (IPT), laboratories where hazardous chemicals are utilized, facilities must conduct a formal chemical risk assessment (CHRA). A certified assessor must physically audit the workplace to evaluate exposure level and ensure control are functional.
Hadi, you've spoken heavily about the employer's strict legal responsibilities to provide the SDS, the training, and the high-end engineering controls like clean foods. But what about the worker side of the equation?
That is exactly where the text of the law come in, specifically through Section 24 of OSHA 194. This section focuses entirely on the duties of employees. It clearly dictates the workers must cooperate with their employers, where with provide PPE correctly at all times, and avoid potential misuse or damage of safety equipment. If a worker refuses to wear their respirator or bypass an engineering control, the legal consequences in Malaysia are incredibly severe. Under the law, an employee can face individual fine up to 20,000, imprisonment of a term up to years or both. This underscores the reality that safety a tripartite shared responsibility. The employer must fund, provide, and train, but the employee is legally obligated to execute and complete.
We have analyzed long-term health risks like noise and toxic chemical exposure. Let's pivot on immediate existential threats to the industrial asset and human life. Fire. How do we systematically apply risk assessment tool to fire safety within manufacturing facilities? Okay. First, safety can be based on a large OSH scope. It requires a deep understanding of basic physics and management cycle. It starts fundamentally with a fire triangle. To create a fire, you must have a three-element present simultaneously: oxygen to present the immediate air, fuel such as a chemical solvent, woven pellet or cardboard packaging, and heat and ignition source like an electrical short circuit, hot surface, or static spark. If you remove just one side of this triangle, the fire cannot exist or is instantly extinguished. When we build a hierarchy register for the fire safety, we start with this first step is identify hazard. This means physically mapping out every single fuel source and every single potential ignition source in the factory. Next, we run a risk assessment to calculate the risk rating by analyzing probability and severity. We ask ourselves, if a fire break out our chemical mixing room, how bad could it consequence be on an industrial risk metric? Because of the high likelihood is rapid flame spread and structural collapse. A factory is almost rated at the highest tier of severity, fatal or major. Okay. Once you have a high risk rating on your metrics, how do you experience that try to move from a theoretical assessment to actual? I declared prevention on the plan floor. We operationalize it by embedding fire safety directly into a classic PDPCA plan to check and act cycle. This ensures that fire management is not a static document, but a living system to continue improvement. Okay, first, plan. This is where we design our emergency response plan, ERP. We map out a clear evacuation route, assign, assembly point, establish an emergency command structure, and design the flow layout to keep the violets field far away from the electrical switchboard. Next, do. We implement physical protective infrastructure. This includes installing fire alarm, smoke detector, and approximate fire extinguisher, CO2 for electrical fire, and foam for chemical fires. We also enforce strict operational methods like look out or take out. Actually, it called LOTO system. LOTO ensure that during machine maintenance, electric and thermal energy source are physically look out, preventing an additional spark that could emit residual fuel. Next is check. We audit our preparedness. This means running regular unannounced fire drills to verify if employees can evacuate within target timeline and conducting mandatory statutory inspection of our fire pump with sprinkler pressure and extinguisher expired date. And the last one is act. We review the data from our check. If the fire drill reveals that worker jam at the specific exit outdoor, we can take correction action, widening the or changing the exit direction to continuously optimize the system before a real emergency strikes.
It's interesting look at this because fire safely relies heavily on automated engineering control, like heat-activated deluxe sprinkler system and fire rate wall. This site very high on the hierarchy of control.
Absolutely, Syakirin. And now that loop right back to the human factor theory we discussed earlier. Humans are prone to panic, error, and lapse in judgment during the emergencies. By focusing our capital expenditure and high-level engineering control like automatic transmission and fire containment barrier, we build a resilient ecosystem. Even if a human makes the critical operational error, the built environment is designed to contain the energy to prevent a localized incident from becoming a total facilities catastrophe. Okay, next, up to this point, our conversation has focused primarily on the what happened incident inside the factory walls to protect the workforce. But modern manufacturing doesn't exist in a vacuum. It have a very heavy footprint on the surrounding world. Kenny, how do you organize managing this external impact? How does the ISO 14000 standard help?
manufacturing processes are inherently transformative. They take raw materials and energy and convert them into finished goods. Unfortunately, that transformation inevitably generates waste and emissions across all major vectors of pollution: air pollution, noise pollution, water pollution, and soil pollution. On a macro scale, these localized outputs scale up to global environmental crises, accelerating global warming, destroying biodiversity, and creating acid rain that compromises entire ecosystems. To manage this footprint responsibly, forward-thinking organizations adopt an environmental management system, or EMS, under the ISO 14001 standard. Just like OSH uses systems to manage risk, ISO 14000 provides a structured management framework that forces an industrial facility to look at its operations through a life cycle perspective, committing the organization to compliance, pollution prevention, and continual improvement.
When a factory is dealing with a substantial volume of industrial waste, whether it's chemical, sludge, or packaging waste, is their preferred strategy for handling it under this modern environmental standard.
Yes, we utilize the waste management hierarchy, which mirrors the logic of the OSH hierarchy of control by prioritizing prevention over mitigation. Starting off, the most preferred is source reduction and reuse, followed by recycling and composting, then followed by energy recovery. And the least preferred is treatment and disposal. At the absolute top of this hierarchy sits source radiation and reuse, which we have often operationalized as prevention through design, or PTD. Instead of trying to clean up pollution at the end of a pipe, you go back to the drawing board. Can you redesign the manufacturing process to use non-hazardous water-based solvents instead of volatile organic compounds? Can you work with suppliers to receive raw materials in reusable totes rather than single-use cardboard boxes? Recycling and energy recovery, such as capturing the heat from an incinerator to generate steam, occupy the middle tiers of the hierarchy. At the absolute bottom, the least preferred, last resort option is chemical treatment followed by disposal in situ landfills.
This details a perfect feedback to our open discussion on legal framework. Doesn't it? Because in Malaysia, this isn't just about corporate social responsibility, it's heavily policed.
Precisely. Inside the factory, you answer to OSHA 1994 and the Department of Occupational Safety and Health, (DOSH). The moment an emission or waste stream crosses the factory boundary line into the public sphere, you are strictly governed by the Environmental Quality Act, E2A 1974, enforced by the Department of Environment, DOE. What companies are realizing in 2026 is that implementing an integrated ISO 14001 and ISO 45001 system isn't an expensive regulatory burden. It is an economic strategy. By minimizing waste at the source, companies drastically reduce their raw material costs, lower their waste disposal fees, and insulate themselves from crippling litigation and regulatory shutdowns. It builds invaluable community goodwill, which mitigates risk and drives long-term profitability.
This has been an incredible enlightening session. As we wrap up our panel discussion today, a powerful theme has emerged. OSHE is not a collection of fragmented, isolated rules. It's a fully integrated strategic discipline where we are managing workplace noise, hazardous chemical materials, immediate fire threats, or environmental pollution. We are using the exact same core management tool, proactive hazard identification through the 5N, risk rating through hierarchy, and systemic education via the PDCA cycle.
Absolutely, Veron. And as final takeaway for the plant managers listening, we must always keep the iceberg theory of accident cost in mind. The iceberg visible, the visible cost of a workplace accident, like insurance, medical payment, and worker compensation, represent only the small tip of the iceberg above water. The hidden and uninsured costs lurking beneath the surface, including lost productivity, machine downtime, accident investigation timelines, legal fees, and damage to corporate reputation, are 2 to 36 times higher than the insured cost. Spending money on proactive safety control is an investment that preserves capital.
Ultimately, safety is not just about compliance checklists or avoiding fines. It's about engineering a culture where every individual, from the managing director to the newly hired operator on the line, takes personal ownership of the risks.
Yeah, thank you so much to our outstanding panel of experts, and thank you to your audience for your time and engagement. By deeply understanding our regulation history, acknowledging a human factor, and strictly executively structured risk management, we can achieve our ultimate goal, ensuring that every single worker return home safely to their families at the end of their shift, while preserving our shared environment for generations to come. Have a safe and productive day ahead. That's all from us. Thank you.